Okay, so you should have 3 items for chapter 8. Hold off on the little chart and the T table. Yes, this is a T table. If you look up at the top, it's a T, not a Z. For just a second, we're going to get to both of those in just a minute, but let's just talk just really briefly on this first page about what you need to know. So in chapter 8, we are going to be estimating. That's the whole point of chapter 8. We're going to estimate. So what happens is sometimes you can't get real data, right? You can't get true data about populations. It's just not possible. So you take your sampling distributions that we talked about in chapter 7, you take your samples and you use the information from the samples to estimate what your population parameters are going to be. So we're estimating. This is basically all about creating confidence intervals. So when I say we're estimating, what we're going to have is two little parentheses like this. Okay. And you're going to have a lower value as your first number, comma, and a higher value as your second number. That's your confidence interval. So what you're basically saying is you are 90% sure the true value lies between those two numbers. Or maybe you're 95% sure the true value lies between those two numbers. So you're going to be estimating, and you're going to give a confidence level of how sure you are that the true value is in that little interval. So that's what we're doing. Okay, first thing we need to do, even though this sounds like a really bad math skit or joke, make sure you know these 3 definitions, okay? I almost said my math lab. For Wiley, it's going to ask you these 2 definitions. That's your very first question right out of the gate, okay? And basically, an estimate assigns values to a population parameter based on a sample. An estimator is a sample statistic used to estimate a population. So they're the opposite of each other, okay? So make sure that you're comfortable with that, because that's going to be a Wiley question, just those definitions. That's it. All right, and then we talk about 2 types of estimates, point estimates and interval estimates. Point estimates we're not really concerned about. This is just saying that X bar is the same as mu. We already knew that from chapter 7. This is going to tell us P hat is going to equal P. We knew this from chapter 7. These are just going to be point estimates that we already talked about. We are interested in this chapter in interval estimates, the lower value, the higher value, that kind of thing, okay? All right, we're also going to have a margin of error. So this number, you're going to add or subtract to your mean to create your interval, okay? So that's going to tell you how far it could be on either side of your mean. And we'll get to that. All right. I know we're just flying through this, but let's come down here. So remember, we're using sampling distributions. So our standard deviation is going to have to be divided by the square root of the sample. Same thing we did in chapter 7. Each little chapter builds on itself in statistics. Okay. All right. So, and then this is interval estimation. Interval estimation, you're just constructing a little interval around something. That's it. All right, well, we are going to then skip that example at the bottom, and we're actually going to skip this whole next page, okay? Because this whole next page deals with coming up with a Z value based on your confidence level, okay? It shows you how to derive it, how to come up with it, how to make it work. Well, here's the thing. We show you all that, but then you never do it again. That's where this chart comes in. So I figure you guys probably don't need to know how to do all that if you're never going to actually have to do it. So we're going to get rid of this middle column. And what this does is it gives us, given a confidence level, how confident are you that this is your interval estimate? It gives you a corresponding z value that we are going to be using in our equations. Now, I know for 90, it gives you a choice, and for 99, it gives you a choice. Wiley likes the bigger version of each of those. So circle these two or cross the smaller ones out, whatever you want to do, but those are the two we want to use. So in our formula, you're going to have a z. You're not going to use your calculator to find z. You're not going to use a z chart to find z. You're going to use your confidence level. So if they tell you to make a 97% confidence level, you're going to put in 2.17 for your z. See how that works? So this you'll be able to use on your test. You're going to want it on your Wiley. And then if you want to see how these values were derived, that's what this whole page does. It derives each of these values. You can go on there and watch a little video of me doing it, okay? If you're just dying to know one night when you're bored. Okay, so there you go. Now, there are 3 types of interval estimates that we're going to be dealing with. Okay, so I'm going to write that down here. 3 types of interval estimates. Here's where the nitty-gritty comes in. Your first type, sigma, is known. Okay? Now remember, sigma is your population standard deviation. So as you're reading the problem, if they give you sigma, this is the type you're going to use. All right. Second type, sigma's unknown. This is the most realistic version that you're going to come across. Normally, we don't know that. What is known is S. Remember, that's your sample standard deviation. Okay. And the third type is going to be a proportion. And we've been dealing with those in chapter 7. So that's what we're going to deal with in this chapter is we're going to make an interval estimate for each of these 3 types of problems. That's what's going to be on your test. That's what you need to be comfortable doing. Okay. Now, just so you know, might be something you want to write at the top of your little, this little page here. This is for sigma is known, and this is for proportions. That's what this chart is for. It is not to be used when sigma is unknown. That's where your T chart comes in. Okay, we're going to go through all of these in detail now. We're going to slow down and really go in detail. So the T chart is only for sigma unknown, in case you want to write that at the top of your T chart. Sigma unknown. That's it. Okay. This particular chart is sigma known and proportion. All right. So I know that was a very fast, like you don't even know what just happened, kind of introduction to this, but that's kind of the nitty gritty into it. And now we're going to take a look at each particular type, and we're going to do lots of examples of each type so that you kind of get the hang of it. So 8.2, that's what this little guy is. This is the interval estimation of the mean for when sigma is known. Okay, sigma known. That means we're going to get to use this chart, right? This guy here. Okay, so we're not going to stay on this page too long. We're just going to kind of talk about it a quick second, and then we're going to do our additional examples, because that's when you really learn the most, is when you do the examples for Wiley. So these can be a little confusing. I'm not thrilled with how they wrote this. I don't make these packets. I only stick in the additional examples. So let's just kind of, I'm going to kind of fix these up a little bit here. Okay, when sigma is unknown, to get your interval estimate, you're going to take X bar plus and minus your margin of error. That's E. That's going to give you your estimate. X bar minus E gives you your smaller number. X bar plus E gives you your bigger number. That's how you come up with your interval. All right, well, that's great, but what's E, right? How do you find E? All right, well, first of all, X bar and mu are the same thing, right? So if they don't give you X bar, that's okay. You know that's really mu. That's a point estimate that we know to deal with. Okay, how are you going to find E? All right, well, your margin of error is going to be Z from your little chart times sigma X bar. Okay, now we got to think about this a minute from chapter 7. What is sigma X bar from chapter 7? Do you guys remember? It's sigma divided by the square root of the sample, right? So when I say E, what I really mean is Z times sigma divided by the square root of the sample. That's what I really mean, right? Because this is really square root divided by square root of n. I'm sorry, is really sigma divided by the square root of n. Okay. All right, that's your formula when sigma is known. Okay. Now, let's go down here, talk about these very last little starred numbers, and then we're going to practice some examples. Okay, notice this. The true mean may or may not really be in the interval. It's okay if it's not, it's just an estimate. Estimates don't have to be exact, right? So if your true answer is in it or not in it, that's okay, all right? Now, when sigma is known, how can you control the width of this interval? What if you feel like the interval's too big, or you feel like the interval's too small, and you want to control the width of this interval you're going to make? All right, you can do this using the value of Z, which depends on the confidence level, and by using the sample size N. And these two next sentences tell you how those are affected, okay? So lowering your confidence level, going from 95 maybe to 90%, making it lower, reduces the width of your confidence interval. So the smaller your confidence level, the smaller your confidence interval, right? The smaller the percent, the smaller the confidence interval. So those are proportional to each other. They happen the same way. The N is going to be the opposite. The larger the N, the smaller the confidence interval. And when I say smaller, I mean not as wide. It's a more narrow interval. Okay, we'll look at that when we do our examples. I'm just throwing all your little info out here real quick. So we're going to be able to make this interval here. And it really is going to depend on your margin of error, which depends on your sample size. Well, we always know there's a shady side to statistics, right? Where a lot of times you can work backwards to get what you want your numbers to say. So let's say we want a certain margin of error and we want things to come out correctly. Then if we work backwards, we can sort of reverse engineer and get the numbers we want by getting the sample size we want. And so that formula is going to be Z squared times sigma squared, because remember sigma is known at this point, over your margin of error squared. And you always round up, right? Even if you have a 1.2, you're going to round up to 2, right? Always round up in statistics. Okay, and now let's just do a bunch of examples. So we have how to find the sample size when sigma is known. And we also know how to find our confidence interval when sigma is known. Okay, so let's flip it over and start on number 1. Is everybody okay with that? All right, here we go. So this says, okay, for a population data set, sigma is 12.5. Okay, right there alone, that's huge. This tells us sigma is known. Okay, good deal. How large a sample should be selected so that, now here's where it gets a little wonky. Read this. So that the margin of error of estimate for a 99% confidence interval, this is going to give us Z, for mu is 2.50. All right, so what does this problem want? It is so wordy. It's just like it's not even English. It wants a sample size, right? That's what it's asking for. So since sigma is known and it wants a sample size, that's what we had just written over there. We have Z squared times sigma squared over margin of error squared. All right, let's read through these numbers again. I have Z because I can get it right off my chart. I have sigma, they gave it to me right here, but what in the heck is this number? Because if all you're doing is scanning and pulling out numbers, you might say, oh, that's mu, mu is 2.50. That's not mu. This is your margin of error. Read that whole sentence, it's so confusing. The margin of error of estimate for this for mu is this. That's what's so tricky about these problems. That's actually your margin of error. So anytime they say margin of error, they may say the margin of error of estimate for mu. Okay, they may not just say margin of error. Margin of error for an of estimate of mu. That whole thing is going to give you a number, and you don't want it to get confused with another symbol. Okay, so we should have everybody we need, and it's just a plug and chug situation. So 99% confidence interval, that's going to take me here. For 99%, what's my Z going to be? 2.58. We're just pulling it right off of our little chart. Okay. Now notice everybody is squared on here, so make sure you square everybody. Sigma is 12.5 squared over a margin of error, which is 2.50, and that's also squared. Okay, so if you square everybody, I came up with 166.41. Now, remember, for a sample size, you want a whole number and you always want to round up. So what is our actual answer going to be? 167, because you always round up. Even though in algebra, this would be 166, you're going to go up. Okay, that's all right. Okay, let's try another one here. Okay, this one says, a bank manager wants to know the mean amount of mortgage paid per month by homeowners in the area. We have a random sample of 114 homeowners. That's in. Showed that they pay an average of $1,573 per month for their mortgages. So what is $1,573? And that's our average. How are we going to say that? That could be X bar, which is also going to be mu. It's all the same thing, okay, for this. And then it tells us the population standard deviation is 209. What's the symbol for population standard deviation? Sigma, right? So Just so happens, sigma is known. Now I know you're thinking, yeah, Ms. Holcomb, because that's all we know how to do. Right, but we got to keep talking about it because I want you to be able to pick that out, because on the test, the problems will be all mixed up and you're going to need to know which formulas to use, okay? All right, then it tells us we want to find a 99% confidence interval for the mean amount of mortgage. Remember, when sigma's known, this 99% confidence interval gives you Z. So if we go to our little chart again, 99% ends up being 2.58. Okay, so let's see if we remember our formulas here. We want a confidence interval, which means X bar plus or minus E, okay? We also said that E is gonna be Z times sigma X bar, which is sigma divided by the square root of N. Okay, well, I already have X bar, so I'm not worried about him, but let's find our margin of error now, okay? So our margin of error is gonna be Z times sigma, which is 209, divided by the square root of 114. Okay. Now, whenever you're finding E, it's always a good idea to go out 2 or 3 decimal places just to make sure that you have, you know, plenty on there. I think I only went out 2. I went out and I got 50.50. Okay. Everybody okay finding margin of error? Okay, now all I'm going to do is take X bar plus this number and X bar minus this number. And then I just put them in little parentheses and I'm done. So X bar, whoops, yeah, I'll do it like this, minus E, and I'm going to have X bar plus E. So I'm going to have 1573 minus 50.50, and I'm going to have 1573 plus 50.50. And that's going to give me a smaller number of 1522.50 and a bigger number of 1623.50. And this is my 99% confidence interval. And that's how you do it. Okay. Is everybody comfortable with that? So I found my E, then I took my mu or my X bar. I did X bar minus E, that was this little number. And I did X bar plus E, and that's that bigger number. And I just put them in parentheses with a comma between them, and I'm good. Is that okay? Okay. All right, letter B says, suppose this is too wide. How can it be reduced? Okay, well, if we want to make it smaller, then we can lower the confidence level, because those two go together. When one is big, the other's big. When one is small, the other's small. The sample size is the one you do the opposite on because it's in the denominator. So if we want to reduce the interval, then we want to increase the sample size. Okay, so I'm going to write a little statement down here just to kind of help you here. As width of interval decreases, confidence level decreases. Oops. And vice versa. N is the opposite. I don't know if that helps you at all, but just put that down there. So your interval and your level, those go together. As one increases, the other increases. As one decreases, the other decreases. Vice versa, but N's the opposite. Whatever N does, the opposite thing is going to happen with the other two. Okay. Okay, let's try 2 more examples like this. Everybody okay with that? Okay. All right, let's look at number 3. All right, so the standard deviation for the population is sigma 7.42. Okay, so automatically sigma is known. That means we're going to use this chart. That means we're going to use the formulas we talked about. You know, it's important we know that. Okay, a random sample from this population gave a mean equal to 48.37. Okay, that means our mu and our x bar, because they're going to be the same, is 48.37. Remember, that's what we're going to add and subtract the margin of error from. Okay. All right. Construct or determine, depend on what Wiley says, they're both the same thing, 95% confidence interval. All right, well, that's Z. So we're going to go to our little chart. Now 95 is going to change our Z value to 1.96. Okay. All right. From you, assuming N is 196. Okay. So remember, we're going to do X bar plus or minus our margin of error. And our margin of error is going to be Z times sigma over square root of N. Okay. So here we go. Let's find our margin of error first. We're going to have 1.96 times 7.42 divided by 1 square root of 196. Okay, I came up with 1.04. Then I'm going to take 48.37 minus 1.04 and 48.37 plus 1.04. And that's going to be my interval. So this smaller number, I came up with 47.33. The bigger number was 49.41. And there's my interval. Okay. Not too bad. Everybody okay with that? All right, let's try one more then. Okay, and then we'll look at what happens when sigma is not known. Some different formulas, and we use our T-chart. Okay, here we go. A city planner wants to estimate the average monthly water use. He selects 40 households, there's our N, which give a mean usage to be, that's our mu, our X bar, 3,406.80. I don't know what that M is, gallon, metric, meter, something. What do you think it is? Huh? Million gallon. Million, that makes sense. Okay, over a 1 month period. Good job. Okay, based on earlier data, the population standard deviation of monthly water use is this. This means sigma is known. Okay, so our sigma is 387.30. All right, everybody kind of getting the hang of figuring out what the numbers are? That's the hardest part. Okay, we want to make a 97% confidence interval. Since sigma's known, we go to our little chart. 97% is 2.17. Okie doke. So we're going to take X bar plus or minus our margin of error. Okay, remember our margin of error is 2.17, that's our Z, times sigma divided by square root of N. And I came up with 132.89. Okay, then remember we take X bar or mu, we're going to subtract our E, and then we're going to take it and we're going to add our E. And that's going to give us a nice little interval. So our smaller number is 3273.91. Our bigger number is 3539.69. Something like that. And there we go. Okay. So there's sigma known. Everything I can think of to do with that. Does that sound okay with everybody? Okay. Your proportions are going to be extremely similar to this, and we'll get to that in a minute. Unfortunately, the little wrench gets thrown into things on the next page when we don't know sigma anymore. That's when it becomes really stinky. Okay, so we're going to go through this and kind of talk about this a little bit. All right, when you don't know sigma, when it's unknown, they're instead going to give you S, the sample standard deviation. It's going to it's going to sound a whole lot like sigma. So you really have to be alert. You have to be on your A game when you read these paragraphs, okay? This is reading comprehension 101 here. Okay, so for samples where the population is approximately normally distributed and sigma is not known, your population standard deviation is not known, you're going to use the T distribution. So we can no longer use this. We're using this. This is what we're using now, okay? This distribution only has one parameter, df. Those are called the degrees of freedom, okay? And that's totally dependent on sample size. Degrees of freedom are just n minus 1. So whatever sample size they give you, subtract 1, and those are your degrees of freedom. And notice they're located over here on the left side of the page. Now, once you get to a degree of freedom of 75, after that, they just say infinity because the numbers, the area really doesn't change. So anything higher than 76 or 75, I guess, you just use, oh, you can't see, it's your little heart. Okay, you just use the infinity, okay, down there at the bottom. All right, so how are we going to find the T value from the table? Well, we're going to find the degree of freedom, but then the next thing we have to have is this little area up here, okay? This little number across the top. You have to find that based on the information given. Here's how you do that, okay? It's 3 steps. First step, you're going to make your confidence level into a decimal. So they're still going to tell you make a 90% interval or a 95% interval, but you can't use this. That's what you have to remember. When they give you these values, don't run to this chart. If sigma is not known, change that percent to a decimal, okay? Second step, you're going to use this little formula, 0.5 minus your confidence level over 2. This is going to be your area, which are the values on top of your T chart. Third step, you need to find your degrees of freedom. And we already know that's n minus 1. And then that will give you your T value, okay? Now, your T value is going to be positive unless they mention the end of the tail that it's in, okay? So I'm just going to write up here on the top that your T value will be positive unless it tells you that T is in the left tail. Then make it negative. Okay. If it tells you T is in the right tail, it's positive. If they don't mention anything at all, it's positive. But if they mention it's in the left tail, you're going to make it negative. And that kind of makes sense if you kind of compare it to a Z chart. Okay. All right, so let's find our formula now that we know all this. This is simply to find the t value, okay? That's all that this is. All right, I'm going to kind of scratch through this stuff here and give you a better explanation, okay? And your explanation is going to be that it's still x bar plus or minus e. That hasn't changed. That's still going to be how you find your confidence interval. The only thing that's changed is your margin of error, okay? So remember, your margin of error was z times sigma over square root of n. Now your margin of error is going to be t, because we don't have z anymore, times s of x bar, which is going to be t times s over the square root of n. Okay, so this is your new formula. It's going to be t instead of z, and we already know how to find t. It's a little more complicated. And then instead of sigma x bar, now it's sx bar, which is just s over your square root of n. Okay, so very, very similar. Instead of z, we have t. Instead of sigma, we have s. Otherwise, it's the same. Does that make sense? Okay, so let's try this problem. Okay, this is going to be our first example. And then we will go on and look at some additional examples. But I want to try this one because I don't have an additional example one like this. So this broke it down pretty easy for us. It gave us n, it gave us x bar, it gave us s. So as soon as you see s, you know sigma is unknown. That means get your t-chart ready. That's what that means. Okay, this 95% does not mean that you run to your z-chart, right? That means we're going to have to come up with a t. Okay, so here we go. This has us do it in kind of a weird order, so I'm not really thrilled with this. I mean, I'm just going to kind of, sorry, I just kind of want to stick with the plan that we've been doing here. Okay, so first thing that we're going to need is to find our margin of error. Now, before we can find our margin of error, we need t, right? So let's find t. Okay, here we go. Our confidence level is 95%, so we're going to change it to 0.95. The area that we're going to find up at the top is going to be 0.5 minus 0.95 over 2. Where did I get that crazy formula from? Right here, right? Okay. Make sure you can find that in your calculator. I came up with 0.025 was the area that I came up with. My degrees of freedom are going to be n minus 1. Well, my n is 25 minus 1 is 24. Okay. Everybody okay with that? All right, and we're going to go to my t-chart now. Okay, degrees of freedom, 24. My area was 0.025. Here's my t, 2.064. Does that sound good? Okay. 2.064. Okay, great. Now I'm ready to find my margin of error. So I have my t, 2.064, times s divided by the square root of n. Okay. It's going to give me a margin of error of 4.95. And now I'm ready to do my x bar plus or minus e. So I'm going to have 186 minus 4.95 and 186 plus 4.95. The smaller version I got was 181.05, and the bigger version was 190.95, and that's my answer. Okay. So I didn't lay out any key formula sheets for you guys, but this would be something that I would put on your key formula sheet, right? These three little steps are not going to be on there, but when we start reviewing for test 4, we'll make sure that we put on your formula sheet what you need, but this would be a good idea. So hopefully you see that sigma unknown is not, terribly different. It's just that you can't look and read it, a T right off of the table like we did for Z. You have to find it. But once you find it, it's so similar. It's not that bad. Okay. All right, let's do this next page. And then we go into proportions. Okay, so I couldn't fit this part on the other page there, but this says to now construct a 99% confidence interval for the same data. Okay, the same data. So T, let's see, T is going to change. Yeah, so let's just kind of remember what we did here. Let me go back here. For this data, N was 25, X bar was 186, and S was 12. Okay, there we go. All right, I'm going to kind of get rid of this. Okay, and we'll just kind of do it our way there. All right, so we want a 99% confidence interval. That means that first we need to find T. Okay, so we're going to find our area, which is going to be 0.5 minus 0.99 over 2. That's going to give us the area at the top of our T chart. Everybody agree with that? The only thing I changed was this. The 0.99 went up there. This gives me an area of 0.005. Little teeny tiny area. Okay, my degrees of freedom aren't going to change. It's going to be 25 minus 1, which is 24. Okay. And now I'm going to go to my T chart. Okay. So 24, here's my degrees of freedom. But now my area is itty bitty. It's 0.005. And so my T is now 2.797. Sound good? Okay. 2.797. All right. So now we're ready to make our confidence interval. So my E is going to be T times S divided by the square root of N. It's going to give me an E of 6.71. My X bar is 186, so I'm going to have 186 minus 6.71 and 186 plus 6.71. Now this little CI, that's confidence interval. So they kind of have your parentheses set up and your comma in the middle. So the smaller numbers, 179.29, comma, 192.71. And there's your confidence interval. Now, if you compare that to the confidence interval on the other side, our confidence interval increases as our confidence level increases. So this interval got wider because this number got bigger. If you look at it on the other page, right? And we knew that was going to happen. We know they go together. Everybody remember that? Okay. All right. So then these are just some little additional problems you're going to find in Wiley. So let's look at these three. Okay, so we haven't had to deal with that left tail thing that I told you might come up. Well, here it is. So number one, all they want you to do is find the value for T. They just want you to play with the T chart. Find the value of T. Sample size of 14. Well, that's good. That's your N. Can I use N on my chart though? No. I have to use degrees of freedom. So what are my degrees of freedom going to be? 14 minus 1, right? It's always N minus 1, okay? And then it gives me an area already. but it tells me this is in the left tail. So is my t going to be positive or negative? Negative, because it's in the left tail. So I'm going to use degrees of freedom 13, and I'm going to use an area up at the top of 0.025, and I get 2.160, but I'm going to make it negative. Now, why are we making it negative? If you read up here at the top of your T-chart, these are areas in the right tail. Notice that Z-chart gave us areas in the left tail. So we never had to make anything negative, and they had positive and negatives on both sides. This T-chart doesn't have any negatives anywhere. It only has positive degrees of freedom, right? Because it's a sample size -1. So there's no way to represent negatives. You have to think and use your little brain to get the negatives. They don't provide them for you. So anytime you see left tail, you're going to make it negative. So negative 2.160. That's all, that's your answer. Okay. Now, number 2 wants you to find a t also. Just play with your T-chart. Okay. Gives you a sample size, but we want degrees of freedom. So if our sample is 22, what are our degrees of freedom? 21, right? Now on your test 4, it's going to have questions just like this, and it will have the answer if you use 22, and then it will have the answer if you use 21. So you want to make sure that you don't forget to do n-1. Okay, here's our area. Now this tells us right tail. So we're going to leave it positive. Your t is always positive unless it says left tail. So I'm going to go to 21, and I'm going to scooch over to 0.10, which is right next to it, 1.323. Okay. And there we go. Everybody okay using the T-chart? Okay. All right. So why did I make a big deal about sigma unknown being like the bane of my existence? Well, here, this is why. Ta-da! Okay, because this happens sometimes. It will happen on test 4. It happens like 3 times on Wiley. Okay, what does this tell us to do? Let's see. A sample of 6 observations, we hadn't had that in a while, so our n is 6, taken from a normally distributed population, produced this data. Bam, there's your data. A says, what is the point estimate of mu? Well, the point estimate of mu is x bar. That's our mean. It didn't give us a mean. B says, make a 90% confidence interval for mu. Did it give us sigma? Sigma's unknown. Well, to make sigma unknown, I have to have T and S. Did it give me S, the sample standard deviation? No, it gave me nothing but these numbers. Think way back, dig super deep, folks. You're going to 1 bars stat. Remember that? We're making a list. We're putting all the numbers in, and that is going to give you X bar and S. That is your goal. You have to get those 2 values. You need X bar and you need S. And so 1 bar stat gives you that. So let's see if we remember how to do that. Okay, so for my people being recording here, we're switching to our calculator. Okay, all right, and we're gonna have to put these values in a list. So remember, that's stat, edit. Remember, stat, edit. That's how you get your list. And then you're gonna put all 6 of these values in for L1. There they go. They're all getting put in here. And then once you have them all in there, if you don't remember what to do, go ahead and quit. Okay, you'll do second mode and quit, but we want everybody in there. So that's stat, edit. Okay. All right, once you get stat, edit, we're going to second mode, we're going to quit. Then we're going to do stat, scooch over to calc, 1 var stats. Now, all we have is L1. So we're going to do second, 1, and then we're done. On the fancy schmancy calculators, what does it tell you on those though? It's like a list and then frequency list. Okay, thank you. So, and list comes first. Okay, so on list, put L1, and on frequency list, make sure it's blank. We don't want anything on frequency list, okay? And then see if you get this. Does everybody get that with theirs? So list should be L1, frequency list should be blank. And then this is what we come up with. Is that good? Okay, so from this, you want to write down X bar. Okay, oh, this wants 3 decimal places. So 23.817, that's my point estimate for mu. Okay. And then we also want S. Now, don't let this confuse you. This on the calculator, it says S of X. It's not. It's just S. That's also kind of an issue. So our S is going to be 1.6142. Take him out a little bit. Okay. This is just S, even though it says SX. Everybody okay with getting that info? Okay. That's all you need 1 var stats for. Okay. Now we're able to go on and finish this situation. Okay. So we have our X bar. We need to find our E, which means we have to find T. Okay. So remember, the first step to find T is to find our area. So 0.5 minus, we're going to take this confidence interval or level, divide it by 100, get 0.90, and then divide that by 2. That's going to give us an area of 0.05. Okay, we also need degrees of freedom. Okay, so there were 6 pieces of information. That means your N is 6, subtract 1, your degrees of freedom are 5. Now it's just like every other problem. So I'm going to go to my T chart. I have 5 degrees of freedom. I have an area of, what did I say, 0.05. So my T is 2.015. Okay. All right, let me find my margin of error then. So it's going to be T that I just found times S, which came from the calculator. It was SX in the calculator, but don't listen to that. Divided by the square root of 6, because I had to have N. It's going to give me an E of 1.3279. Had to go out 4 places because that's what it wanted. So now when I do my X bar plus or minus E, I'm going to have 23.817 minus 1.3279 and 23.817 plus 1.3279. And I get 22.489, comma 25.145. And there we go. Okay, so that's the stinkiest kind of problem you're going to have. You just put it into your 1 var stats, get your X bar and S, and then you have everything you need. Sound good? Okay, let's talk about proportions real quick then. We'll have to finish it on Thursday, but okay, pretty darn good for me as much as I talk. Okay, so we're back to no more T. We get to use this again, where it's just right on the chart and we have everything we need. Okay, so for a proportion, let's make sure we have everything here. Okay. All right, first of all, your point estimate is going to be a little bit different. I'm going to write our information up here since this can be confusing, okay? So your point estimate is going to be that P hat and P are the same thing. That's kind of like your X bar and your mu, right? Okay, that's going to be the same thing. Now, to find your interval, you're going to take p hat plus or minus e. Okay, just like we learned. Now let's just see if we can remember what in the heck is e. Okay, I'm going to come down here and tell you that e is z, right off the chart, times s of p hat. But you already know what s of p hat is. You used it last time. It's going to be z times the giant square root of p hat times q hat over n. Okay, remember this guy from chapter 7? We just had p times q over n, but this time we're calling in the hats because p hat equals p. So q hat equals q. Okay, how are you going to find q hat minus, by the way? Remember, he's going to be 1 minus p hat. He's just whatever, 1 minus whatever his little p friend does. Okay. All right. So there we go. It's going to be the same situation. Okay. So let's say, all right, I'm going to kind of get rid of then this crazy way they have this marked out here. And kind of, we'll just do this example the way that it says it. Okay. All right, let's say 44% of a sample of 1,000 people say religion is very important to them. That's all they're going to give you for a proportion problem. This percent is your p hat and your p. You just have to change it to a decimal. So that's going to be 0.44. Your n is going to be 1,000. Okay. The other thing you're going to have is q hat. Anybody remember how to find q hat? 1 minus 0.44, which is 0.56. Okay, so here we go. I scribbled through everything, but it wanted a 99% confidence level. So if it wants a 99% confidence level, because it's a proportion, we're just going right to this little chart. 99% on here is going to be 2.58 for our z. Okay. Okay, we're ready. Let's find our margin of error. Okay, so we're going to have z times a gigantic square root. And inside the square root, you're going to have 0.44 times 0.56 divided by 1,000. Now, if you don't like to do all that at once, just take it one little piece at a time. That's going to give you an E of 0.0405. Okay, and now we're ready for our confidence interval. So we're going to take 0.44, which is p hat plus or minus e. So we're going to have 0.44 minus 0.0405. And we're going to have 0.44 plus 0.0405. And I got 0.40 and 0.48. Now, sometimes with proportions, they won't ask for the interval. They'll ask for the percentage interval, which happens sometimes. So if they asked for the percentage interval, well, how would you change these decimals to a percent? Multiply by 100, right? Or scooch it over. So this might also be 40% to 48%. That might be another option depending on what they ask, okay? So notice these are a lot smaller because they start out with a p hat, with a decimal, okay? All right, we don't have too much more to do on this. We're gonna have one more finding a sample size where we have to find n. And then we just have a couple of examples on the next page, but this is pretty darn good if I must say so myself. So